The prediction broke before the images finished downloading. Voyager 2's final frames from Neptune carried a storm system that should have stayed. A dark, Earth-sized vortex locked into the planet's southern hemisphere. Engineers in the mission pipeline flagged it as stable, long-lived, structurally persistent, the kind of feature you could build a climate model around. Then the telemetry completed its pass, and nothing about Neptune suggested it would ever change quickly. The visual record was clear: a deep cobalt sphere, and one black wound spinning inside it. The Great Dark Spot. That image became the baseline, but the consequence started forming years later, when Hubble pointed back. The first return image showed Neptune without it. Same planet, same latitude band, same viewing geometry. The storm was gone, not faded, not displaced, removed. The visual anchor now split in two realities: Voyager on one side, Hubble on the other. Storm present, storm absent. And that contradiction hit harder than any theory could explain. Because planetary storms are not supposed to disappear like that, the observation forced a systems problem, not a visual one. Voyager had documented a stable atmospheric engine. Hubble was documenting silence. The immediate consequence was simple. If the storm could vanish, then the model of Neptune's atmosphere was wrong at a fundamental level. Not slightly off, structurally wrong. And that raised a pressure no one could ignore. What else had been misread? The first reaction inside analysis teams was correction. Maybe Voyager caught a temporary phase. Maybe the storm was seasonal. Maybe it collapsed after the flyby window. The system was reclassified as transient. For a short time, that explanation held. Neptune became a planet of short-lived storms. Fast formation, fast decay. High turnover atmospheric cells replacing each other in rapid cycles. But that explanation only worked until the next set of images arrived. Hubble did not just show absence, it showed replacement. New dark spots forming at different latitudes. Smaller, faster, structurally different. The atmosphere was not calm. It was reorganizing. And that is where the visual anchor returned. Voyager's great dark spot on one side of the screen. Hubble's empty blue sphere on the other. Then new spots appearing elsewhere, like displaced shadows. Same planet, different behavior, same expectation, broken outcome. The system had stopped behaving like a stable climate model. It was behaving like a reset engine. And that changed the meaning of the original observation, because Voyager was no longer showing a lasting storm. It was showing a temporary configuration inside a rapidly changing atmosphere. That shift created temporary stability in interpretation. A working idea formed. Neptune's storms were not permanent features. They were convection events. Deep atmospheric upwellings that appear, persist briefly, then dissolve as internal heat redistributes. That explanation reduced tension for a moment, but it carried a hidden weakness. It assumed the energy source was stable, and Neptune does not offer that stability easily. The deeper scientists pushed into the data, the more the prediction failure expanded. Wind speeds inside the old storm system implied energy input far higher than solar radiation at that distance could justify. The planet was too cold, too far, too dim, yet the atmosphere behaved like it was powered from within. The visual anchor returned again. Voyager's storm, structured and coherent. Hubble's atmosphere, empty in that exact region. Then new storms forming elsewhere without warning. Like the system was relocating energy instead of losing it. Not decay, reallocation. That detail broke the temporary model. Because now the question was not where the storm went. It was what system allowed it to exist in the first place. At this point, prediction failure became measurable. Every time a model attempted long-term stability, Neptune invalidated it. Every time a simulation assumed slow atmospheric evolution, the planet produced rapid restructuring instead. And the failure started cascading. Climate models built on gas giant persistence assumptions stopped matching observational data. Jupiter comparisons failed. Saturn analogs failed. Even Uranus data, once considered stable, became less reliable when reinterpreted through Neptune's behavior. The midpoint shift was unavoidable. This was no longer about a single storm. It was about whether gas giant atmospheres could be treated as stable systems at all. Then the strongest contradiction appeared. A long-term Hubble survey captured multiple cycles of storm formation and disappearance. And across those cycles, the same pattern repeated. No gradual drift, no seasonal buildup. Sudden emergence, sudden collapse, sudden replacement. And every time, the visual anchor reappeared in a different form. A dark spot here, gone later. Another there, gone again. Each time, the system looked stable in the moment and wrong in retrospect. That is when prediction failure stopped being a modeling issue. It became a structural limitation. Because the atmosphere was not breaking the model, it was exposing that the model assumed persistence where none existed. The final collapse came when teams tried to unify Voyager and Hubble into a single life cycle theory. They failed. Every unified model either overestimated storm duration or underestimated formation speed. There was no middle ground that survived both datasets. The planet refused to stabilize into predictability, and the visual anchor returned one last time. Voyager's perfect storm image, Hubble's empty blue disk, then a third state layered in analysis overlays. Multiple storms, appearing and vanishing across time, none lasting long enough to anchor a stable expectation. The meaning of the original Voyager image changed completely. It was not a snapshot of endurance. It was a frame from a system in constant rewrite. The consequence was no longer about Neptune alone. It was about every gas giant model built on persistence assumptions. If one planet could erase a storm that cleanly, then duration itself was not a reliable variable. And that removed a key option from planetary forecasting. Long-term atmospheric prediction on gas giants stopped being a stable expectation. It became a probability window with no guaranteed continuity. The opening image now meant something different. Not a storm surviving the cold outer system, but a system that only looks stable while you are not watching long enough. Neptune was not holding a storm. It was cycling through versions of itself, and every observation was already outdated the moment it arrived. The great dark spot did not disappear. It proved nothing stays where prediction expects it to remain. Nothing holds still on Neptune, not even time.